Hypothalamus artificial intelligence, HI, presence. Artificial brains. An artificial intelligence designed in 1990 will become the new artificial intelligence in the next years. Lecture edited by Jesus Velasquez Bermudez. In 1943, Warren McCulloch and Walter Pitts created the concept of artificial neural networks. They published the article, A Logical Calculation of the Ideas Immanent in Nervous Activity. McCulloch and Pitts tried to explain how the brain could produce highly complex patterns by using many basic cells that are connected. Neural networks were growing, and in practice they took the name of artificial intelligence. They were also called machine learning. Starting from the perceptron, the first artificial neuron created, the knowledge of neuronal modeling has evolved, currently having multiple types of artificial neural nets, specialized in performing specific pattern recognition. For this, the basic patterns of ANNs are modified. For example, convolutional artificial neural networks correspond to ANNs specialized in identifying certain types of patterns, such as images. The image presents an example of an ANN oriented to recognize images of numbers written freehand. The result is a discrete indicator associated to the number read. The state-of-the-art of artificial intelligence is the Generative Pre-trained Transformer, GPT. It's a type of large language model, an LLM, and the framework for generative artificial intelligence. It is an artificial neural network used by machines in natural language processing, which is based on the Transformer deep learning architecture, pre-trained using large datasets of unlabeled text, and that can generate novel human-like content. A LLM is a machine learning model that can understand, generate, and translate human language. LLMs are trained on massive amounts of data, such as text from the internet. They can be used for a variety of natural language processing, NLP tasks. Most LLMs have these characteristics and are sometimes widely referred to as GPTs. Artificial General Intelligence, AGI, is a hypothetical type of highly autonomous artificial intelligence, AAI, that would match, or exceed, human capabilities in most, or all, economically valuable cognitive work. It contrasts with narrow AI, which is limited to specific tasks. Super Artificial Intelligence, ASI, on the other hand, refers to AGI that far exceeds human cognitive capabilities. The creation of AGI is a primary goal of AI research in companies like OpenAI, Google, and Meta. A 2020 survey identified 72 active AGI research and development projects in 37 countries. The timeline for achieving AGI remains a topic of ongoing debate. As of 2023, some argue that it may be possible in years or decades, others argue that it could take a century or more, a minority believes that it may never be achieved, and another minority claims that it is already here. The Nobel laureate in physics for his work in AI, Geoffrey Hinton, has expressed concern about the rapid progress towards AGI, suggesting that it could be achieved sooner than many expect. There is debate about the exact definition of AGI and whether modern LLMs, like GPT-4, are early forms of AGI. There is controversy over whether AGI poses an existential risk. Many AI experts have stated that mitigating the risk of human extinction posed by AGI should be a global priority. Others consider that the development of AGI is too remote to think about such a risk. In 2024, John Hopfield and Geoffrey Hinton were awarded the Nobel Prize in Physics for their foundational contributions to machine learning, particularly through their work on artificial neural networks. It should be noted that the seminal concept of artificial neural networks, proposed by McCulloch and Pitts, in 1943, is still the general approach of AI. HI does not find in the literature efforts aimed at giving AI the ability to understand complex mathematical processes, which accurately explain the real world, which is necessary for decision-making that benefits all humanity. The research work continues with AI based on the estimation of data-driven supermodels, without advancing to a hybridization of concepts and visions. Neural networks have grown without paying attention to the structure of the brain's architecture, that is, how the main parts of the brain are connected, the cerebral cortex, the hypothalamus and the hippocampus, and the functions they fulfill. Neural networks developed as the fundamental element of communications within the brain, but without consider how they were connected, a lost component's fundamentals. At first, artificial neural networks were very small and gradually became GPT, in the hope of reaching AGI, which could be associated with a very large artificial neural network representing the entire brain, associated with many models, also very large, that with an infinite number of parameters would represent all the connectivity of the brain, ignoring the smart architecture of the brain. Given this lack of structure, we have a sum of neural network models that produce a supermodel whose networks come together in the brain, as if it were a Lego game in a backpack. The image presents the most detailed map of the brain of an animal ever mapped, a fruit fly. Several research teams have mapped this organ for the first time in an adult specimen, which contains about 140,000 neurons, and more than 50 million connections. Its brain may look small, it has about 1 million fewer neurons than the human organ, but a fruit fly can see, smell, hear, walk and fly. In addition, they socialize, navigate and learn from the experience. Current neural networks work to fill the structure of the brain without studying the structure of the brain, i.e., artificial intelligence without neuroscience. Artificial brains are an invention of HY, due to their expertise in complex modeling. Mainly in mathematical modeling based on an expert system, and in the vision of multi-problem mathematical models for the real world. This vision of mathematical modeling is unique in the world. HY does not know of a commercial product based on these principles. The image shows a close-up of the human brain showing the activation of neurons and neuronal extensions of the limbic system, mammillary pituitary gland, amygdala, thalamus, cingulate gyrus, corpus callosum, hypothalamus. This indicates that the human brain is composed of groups of neurons which in turn are composed of groups of lower-level neurons, or individual basic neurons, called by HY the atoms of the system. The central idea of the artificial brain is to build an artificial intelligence that mimics the human brain, leaving aside the approach of trying to represent the entire brain using a single network of artificial neurons. The creator of the human brain conceived it as the integration of three main organs, or systems: neocortex, hypothalamus and hippocampus. The hypothalamus is part of the thalamus. McCullough and Pitt's theory has been around for more than 80 years. However, Velasquez-Bermudez's work, spanning 35 years of research and technological development, has resulted in artificial brains, which are a new way of thinking about artificial intelligence. Artificial brains emulate the structure of the brain and use it to build the mathematical models. The structure of an artificial brain is made up of the artificial hypothalamus, hippocampus, and cortex, all of which perform functions like human equivalents. The connection between all the subsystems, within and between them, is made by bioneurons. For this, biological neural networks are formed, through which information flows in the brain, and in general in the human body. The neocortex contains millions of neurons that communicate with each other, to capture the world that occurs around the human being. The connectivity of these neurons does not occur based on a dense network, that connects all neurons to each other. Connectivity is based on a sparse network, which can be assimilated to a sparse array. Artificial brains come from neuroscientific studies. The construction of the artificial cortex determines the connectivity of the artificial neurons, which are associated with the atoms of the system. In mathematical models, it is common to use a matrix that establishes the relationship between columns with variables and equations with rows. These matrices are scattered. This is the basis of cortical modeling. One of the scientists who has most influenced HY's work is Jeff Hawkins through his publications, such as Why Does the Neocortex Have Layers and Columns? A Theory of Learning the 3D Structure of the World, and his book 1,000 of Brains, in which Hawkins presents a vision of artificial neural networks based on neuroscientific studies. HY has integrated Hawkins' concepts into artificial brains. Emphasizing that HY is not an expert in neuroscience, its interpretation of the functioning of the brain is presented. The cerebral cortex stores all the connectivity of the neural networks that make up the brain. The hypothalamus is a region of the brain that plays a crucial role in regulating essential bodily functions, including body temperature, hunger, thirst, sleep, mood, and hormone release. In addition, the hypothalamus helps maintain homeostasis, like the body's internal balance, through its connections with the autonomic nervous system and the endocrine system. It can be said that it is the motor of the brain. It is a vital structure for the harmonious functioning of the body, acting as a central control center for various physiological and behavioral functions. The hypothalamus is the organ that ensures the proper functioning of the human being. The connectivity of neurons in the cortex determines how the hypothalamus should function. The hippocampus. Storage structures and processes from the decision-making that must be faced permanently. The artificial hippocampus is based on the mathematical synthesis of the information generated by algorithms and problem-solving processes, to use it in new runs of these algorithms to speed up the problem solution in real time. Artificial hippocampus store, like in the humans, the experience, and the knowledge acquired over time. The hippocampus is responsible for managing memory, which interacts with the hypothalamus, to determine the actions that the human being will perform, that is, decisions. Artificial entrepreneurial brains are based on these hypotheses. Donald Oldingheb is best known for his theory of Hebbian learning, which he introduced in his classic work The Organization of Behavior in 1949. Hebb has been described as the father of neuropsychology and neural networks. The central concept of Hebb's theory is summed up in the phrase, cells that fire together, wire together. According to this idea, when an A neuron is repeatedly involved in the activation of a B neuron, the synapses between them are strengthened. Hebb's theory has shown that learning does not increase the number of neurons, but it does increase the connectivity between them. From the point of view of one part of the artificial hippocampus processes the information stored in the other part, to develop a learning process. Learning takes the form of the generation of new neural connections, which must be stored in the artificial cerebral cortex, to be used in the future by the artificial hypothalamus. This high vision of artificial intelligence, built from the workings of the human brain, is currently unique in the world. From the point of view of one part of the artificial hippocampus processes the information stored in the other part, to develop a learning process. Learning takes the form of the generation of new neural connections, which must be stored in the artificial cerebral cortex, to be used in the future by the artificial hypothalamus. This high vision of artificial intelligence, built from the workings of the human brain, is currently unique in the world. To build an artificial brain, the work to be done is monumental, and it is utopian to think that a superior being, when building a human brain, would do it manually. The first thing he should have developed is the algorithm that produces human beings automatically. In the same way, you can't aspire to build an artificial brain if you don't have the artificial intelligence that produces artificial brains. OPTEX was built as a high-level artificial intelligence that makes artificial intelligences. That is, robots making robots, that make robots like OPTEX, from whom they inherit their characteristics. From the traditional artificial neuron, to build artificial brains, HI has created a new type of neuron, the mathematical artificial neuron. The objective is to integrate the information from the artificial cortex with the communications and actions that the artificial hypothalamus must perform. The greatest advantage of mathematical artificial neurons is that they represent clearly defined objects within a system, that communicate with each other through fully known mathematical laws, and that they comply with laws with transitivity and divisibility laws, in such a way that a system can be atomized, to the level of knowledge that the scientist on duty has. This process leads to the atomization of the system, so that a problem of large dimensionality becomes a large number of problems of very low dimensionality. The parallel processing is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. This means that a mathematical model of a system is composed of multiple problems, related to multiple subsystems, which gives rise to enterprise optimization. HI's research has covered the development of a mathematical language between robots, based on the theory of duality, which is a mathematical law that systems must comply with in the real world. This language is supported by studies by many scientists, starting with Joseph Louis Lagrange in 1978. This gives rise to what HI calls autonomous distributed optimization, in real time. The artificial brains have been designed, following the conceptual results presented in the reports conducted by neuroscience experts. In the process, The similarity between a human brain and an artificial brain for an organization has been discovered in every aspect. If you look at the problem of building a brain, the first big problem to face is the architecture of the cortex, hundreds of millions of connections of human neurons. In the artificial cortex, there will be hundreds of millions of connections of mathematical superneurons, in which each neuron must be built according to the type of function it must fulfill. The science of decision-making using digital computers emerged in 1947 and can be attributed to George Dantzig. HI considers OPTEX, Optimization Expert System, the state-of-the-art for implementing highly complex model algorithms. The AI in which artificial brains are located, HI calls it artificial intelligence for decision-making. An expert system is a computer program that uses artificial intelligence to solve problems. These systems mimic the reasoning of a human expert in a specific field, in this case a mathematical modeler. OPTEX helps professionals who are not experts in a subject, when a problem needs to be solved quickly, accurately and easily, as well as the design and implementation of algorithms. The expert system is specified in a database that stores the model's information and tools to process them. The expert system eliminates the complexity of algorithm programming, facilitating access to mathematical modeling by non-programming expert professionals. Expert systems were created as part of artificial intelligence but not oriented to neural networks. HI has integrated Hawkins concepts into artificial brains. OPTEX is a generative artificial intelligence that can produce infinite lines of perfect source code in seconds. OPTEX replaces a battalion of programmers with a cognitive robot, which interprets the expert system. Albert Einstein said, "Imagination is more important than knowledge. Knowledge is limited, imagination encircles the world." Thank you for your attention.